So now in our second part of today's lesson, we're going to look at how data can be skewed and how we can interpret these box plots when there is skewed data. So we're going to look at a few different things here. First of all, let's talk about the different shapes of box and whisker plots, and let's talk about what skewed means, okay? When we're talking about skew, that means that the mean gets pulled to one side or the other. Okay, the mean gets pulled to one side or the other. Now, how does that actually happen? Well, these extreme values, or if we have a portion of the data that is spread out a little bit more than the other, then the more extreme values on that end are going to pull the mean down below or to the left or to the right of where the median is. Okay, so let's actually start in the middle. In a symmetric distribution, there actually is no skew, right? You'll notice the whiskers are about the same length. The middle, the box is about evenly divided. It doesn't have to be perfect, and these don't have to be exactly the same length, but we're talking about approximately. So while we have the median right here on that value, okay, in the middle of our box, the mean is also going to be about at the same value. It's not, again, that they have to be exactly the same. That would be a perfectly symmetric distribution, which we call a bell curve. You've probably heard of those. And we'll talk about those in our next lesson. But when we have a mean value that's pretty close to what the median is, we say that it's not skewed, it's not, and it's relatively symmetric. Okay, so then we have values that are skewed left, or another way we could say this is that they are negatively skewed. Okay, negatively skewed. It's just another term for the same thing. Negatively skewed, if you think about your number line, the negative values are to the left, so that it's a negative skew. So you'll notice here we have this upper whisker that's relatively short. The lower whisker, though, is relatively long. It's a good, 2 to 3 times longer. And even in the box here, you'll notice that the left side of the box is the data is more spread out than this top side. So while the median, I'm not going to label these every time, but we'll keep the same colors. The median is in blue. These values down here are going to pull the mean over somewhere like right here. Okay, so it's gotten pulled to the left by these lower values. Okay, the left whisker is longer than the right whisker. Most of the data are on the right side of the plot. That's why our median is here. But our mean has gotten pulled over. Now, we don't draw this in our box plot. I'm simply showing this to you to illustrate where it would be, okay? But this has been skewed to the left or negatively skewed. When we're talking about skewed to the right, it's kind of the same idea. It's just the other way. You'll notice our median is right here. The left whisker is relatively short. The right whisker is, again, double or more in length. All right, so this top 25% of our data is spread out a whole lot more than the bottom 25% of the data. Even in the box, again, you see that these are not even. Okay. Now, it could be that your median was right in the middle of the box, but if you have one whisker that's a lot longer than the other, you've got skewed data. Okay. Most of the data are on the left side of the plot. We have these few really high values that skew the mean in the right direction, okay, towards the right. And again, we could call this, instead of skewed to the right, we could say that it is positively skewed. Again, thinking about our number line, we're dealing with positive numbers to the right, okay? So this is positively skewed. All right, and you might hear me use both of these terms as we go throughout. Okay, so let's see how we can use this. Here we have data for 9 nights of sleep, the different hours of sleep that we did. I already put them in order for us, so let's really quickly get our 5-number summary and look at the box plot to see if this data is skewed or symmetric. All right, so our median occurs on the 5th value, since there are 9 values total. So there's 7. That's our median. Okay, and I'm just going to go ahead and draw my number line and put them right on here. Okay, so we'll start at 3, 4, 5, 6, 7, 8, 9, 10. Okay, just drawing this number line and making our box plot. So there's 7. There's our median. Okay. If I look at this data down here, I can see that Q1 is going to occur between 5 and 6. All right. So halfway between 5 and 6 is 5.5. That is my Q1. So I'm going to make the left side of the box right here. And I can see my minimum is this value 4. All right, so there's my minimum. All right, so I'm going to put a dot right there. And now I look at the right-hand side. I see the maximum is at 9. Okay, so I'll go ahead and put that on our box and whisker plot. And my median of these 4, remember we're looking for our quartiles. You look at the data below the median, and then you look at the data above the median. Okay, and the middle value there is going to be halfway between these two 8s, since they're the same value. Q3 is 8. Okay, so there's my 3rd quartile. And now I'm just going to go ahead and draw the actual whiskers. There's my whiskers. Here is my box. Oh, let's try that one again. Okay. There we go. Looks a little bit better. Okay, so as I look at this, I see, okay, well, this whisker is, 2 units long. 2 units long. This one's only 1 unit long. But again, the numbers are so small. Our box inside, this is only 1 apart. This is like 1.5 apart. We could say this is somewhat symmetrical, or we could say that it is just slightly skewed to the left. Okay, you can obviously have different degrees of skewness, but we could say that it is slightly skewed to the left. And again, when you're talking about which direction it's skewed, look at which side has the longer end. All right, so this is a little bit longer than this is, so it's slightly skewed to the left. It's almost symmetrical. Okay. Now, another way we can use this, if we already have the box and whisker plot, this one is actually, if we were to find the range of the data, okay, we're talking about the prices in dollars of soccer balls at different sporting goods stores. Okay, so the cheapest ball that we got was $8.50. The most expensive ball we found was $24.50. So the range is that 24.5 minus the 8.5. So that equals 16. Now it says find and interpret. So that means all the prices or all the balls um, all the balls cost within $16 of each other. Okay. If I were to describe the distribution, notice here, this lower whisker, it's, a little less than 3. This upper whisker is just a little bit more than 4. So that's pretty close to the same thing. Our box, you'll notice, is divided into pretty evenly in half. Okay, so our distribution here, we would go ahead and say is symmetric. Even though it's not perfect, we could say that this is a symmetric distribution. Okay. Now we have the IQR, interquartile range. Our third quartile was 20.25. And the lower quartile is 11.25. And we do the subtraction, we get 9. So that means, remember our IQR, if we're interpreting this, that means the middle 50% cost within $9 of each other. Okay. All right. And then it says, are the data more spread out below Q1 or above Q3? So it's talking about that lower whisker and the upper whisker. Okay, so which one is more spread out? Well, I already kind of mentioned this, but let's look at it more closely. This bottom whisker below Q1, the data goes from 8.5 to 11.25. Okay, so $11.25 to $8.50. Okay, so that has a spread of it's $2.75. Okay, so there's a $2.75% range of values for that bottom 25%. Okay, or the lowest 25%. Okay, that's what we're talking about below Q1. Now above Q3, this is the highest 25%. So we're talking about a range going from 20.25 to 24.50. All right, so 24.50 minus $20.25, we have a range of $4.25. Let me fix that. $4.25. So are the data more spread out below Q1 or above Q3? It would be above Q3. Is spread out. And if you look at the values, it's actually spread out. Excuse me. It's actually spread out $1.50 more. Okay, so not a huge amount, but a little bit more. Okay, so the last thing I want to look at is a comparison here. A comparison. One of the things that box plots are really helpful to use for is to compare two different things in the same scenario. All right, so here we have a double box plot, and these are representing the number of tornadoes per month for a year for two different states. So state A and state B. State A had a minimum of 0, and actually I'm going to go ahead and fill these in as we go. I'm going to identify the 5-number summary. So it had a minimum of 0. So 1 month there were no tornadoes. The first quartile was 4. So 25% of the months, or 3 months out of the year, it had between 0 and 4 tornadoes. Then the median was 7. Then Q3 is 10, the right side of that box, and the max is 14. So in 1 month, there actually were 14 tornadoes. Okay. Now, if you look at that, we can see the shape of state A. A is relatively symmetrical. A is symmetrical. Just by looking at it, you can see here this whisker is about the same length. Actually, it's exactly the same length as the other whisker. Okay. So now if we look at B, you'll notice here the bottom two quartiles, we have this 25%, this 25% are pretty close together. And then you have this 25% and the upper whisker, the top 25%, which are much more spread out. Okay. So B, we would say, is skewed. It's skewed to the right. Okay, because the longer, the more spread out side is to the right. So the mean is going to get pulled over in the positive direction, or to the right. Okay, now just for this other information here, let's go ahead and identify the 5-number summary for B. The min is 4, Q1 is 7, the median is 10. So 4, 7, 10. The third quartile is 19, and the maximum is 27. So if you actually look closely here, you can see the middle 50% for state A is actually the same as the bottom 50% for state B. So state B clearly has significantly more tornadoes on average than than state A. Okay. Now, which state's number of tornadoes is more spread out? Well, clearly state B. And one way that you could explain this is that the range The range is 27 minus 4, which equals 23. But A's range is 14 minus 0 equal to 14. So clearly much smaller. Okay. So which state had the single least number of tornadoes in a month? Well, there, if we look at the MINs, state A had a month where there were no tornadoes at all. So state A had the single least number of tornadoes in a month during the year, because the min equals 0. Okay. And of course, state B had the least it ever had was 4. So every month it had at least some tornadoes. Okay. So I've given you some practice to do. You can do these on the Google form. You've got several different problems. And then at the end, there's actually a little puzzle, because each of these on 5 through 10 is a multiple choice. All right, so you can identify the correct answer and then put the letters together to solve the riddle of what did the tired dishcloth say to the counter. All right, so hopefully that'll be a little bit something to mix it up a little bit. You can practice with this and really master identifying your work with skewed box plots. Okay, have fun.